Okay. Uh, okay, guys. So today I will provide the tutorial, YouTube tutorial on how to do statistical downscaling by using R for Batang Dam in Sarawak. So this is uh, a complete package to do downscaling by using R for the training that we held during the pre-conference workshop for ICD SME. So let me immediately share the screen first. Let's see. Okay. Okay, I will share the screen. So everybody have download this data. Make sure you download this data first. It is in the zip file in the WhatsApp group, and then you can unzip it, and then the data will looks like this. So then next we need to open our R, right? If you not download R, you can download the R first. You can download R. You can download R. Here you can easily find download R 4.5.2. This is the latest version. Up here, you can download and then install. Yes, 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 and everything. Then everything is okay. Then and when you install in C drive. Okay, so that there will be no problem in the future. Okay, after you install R, open your R. I put my R down here in the taskbar, and then you can open R here, and then interface will look like this, and then go to this blue open script and find the R code that I have prepared for everybody. Okay, so it will be the training version, and then we open this, and then I put Windows vertically, and then this is just to arrange the interface so that it looks more user friendly. Okay, put this one here. Okay. Now I will click our editor here. We have our console and our editor. We will work mainly on the our editor where we put our script here. And then I will click control and then zoom in just to make it bigger. So now we have I will repeat again the training that we have before. So before we have this bar, right? We have this bar, hashtag. So this hashtag, if you run this one, run line or selection, it will not run anything because you put bar there. It block the reading of this line. So first, this install package, you remove this bar, hashtag, and then you highlight this all install packages, and then run line or selection. And then it will install. And then this 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 will appear. You just click OK. Everything just OK. And then we wait until the package is installed. Sometimes it's installing again because it is updating the package, because there is some update for the package. So installing again. So it's updated so that your package is updated. So if you see here on the left, it's still installing. The blue color here, that means it's still not finished running anything. We wait until it become red dash, something like that. Not red dash that. I mean this kind of red. It will tell you the installation is finished. So installing the package it's not a big issue. The package is not big. It's only kilobyte, 1 megabyte at most, 2 megabyte at most. Other than that, it's only a few kilobyte. and then uh, and then this package is what is the power of R. Many language or programming language, they have their own package or something like that, and then all equation, all function that we use for calculation is all in this package. Okay, until now it's still installing. Now updating Terra. Now updating Tidyverse. So the speed of this installation and of the package is depend on your computer, the power of your computer, and depend on the power and the speed of your internet also. Okay, So if you want to have look at this YouTube better, you can put your YouTube like maybe 360p or 480p, okay, so that you can read all these text properly. Okay, now that the package has been installed, there will be a red dash, red bar here. So it's finished. Now we run our library, highlight, and then run line or selection. Okay, run line or selection. Okay, now it's installed. It's loading the package now. Next is you need to copy where you put your. Let me put this here a little bit. Copy where you put your grid data, shapefile, and TIFF DEM data. So grid data, we can look at analysis in this folder. So I put here in the analysis. So the data is grid Batang Batang I. So this is, if you open this one, this is CSV file. This is the CSV file. It is the grid location of the chips data for this Batang I that I have extracted. So it has let, long, and grid data. If you save this data, right, you save in analysis, you save it as CSV, not as Excel. You can read Excel also. I don't have any problem to read all of this extension, but most of the time people use CSV, comma delimited to work in R for many analysis. Okay, save as CSV. But here we don't need to save. This is the data already there. So we just need to map this into our shapefile. What is the location of our grid point? So if you want to open that data, you can see here, grid batang.csv, and then this is shape Batang I. So I put here in D research and this folder. So I put here in shapefile folder. So this is my shapefile folder. And then similar thing, I put in the same folder. I put Batang I TIFF file here, DEM file, in the same folder here. So we want to read that data. So all you need to learn using R is that you see this is the folder where we put our data, right? Don't delete this file name. Keep this file name. This file name you don't interfere. You just change the directory here. So this analysis, I copy your folder address, copy, Control C, and then I will paste it here. Okay. Make sure that the direction of that bar is similar with the original that I have prepared. A similar thing with shapefile. I will go to the shapefile. I will copy folder address, and then I will put it in this here. Don't change this .shapefile, okay? Just change the folder address here. And then make sure the bar is in the same direction, all the bar. So please put your dataset not in so many subfolder if possible. It will become difficult. So this one is similar location. You can just copy this one and put it down here. Okay, now it's finished. Now to run this dataset, you run everything from start from the library, run until ggplot until the first section here, before another section down here. Run until here only. Highlight first, highlight everything, and then run line or selection. Okay, now this is our study area, which is Batang I put the DEM based on Allos Palsa. You can play around with this image just to make sure that all the label is correct or something like that. And then this data you can copy. This map you can copy, click right, and then copy as bitmap. So you can put this in your paper or something like that in Microsoft Word. You can paste, and then you get your study area data, right? Okay. So the red one is the chips dataset, the grid dataset of chips. This is all where the location of rainfall data for chips that I have collected. And this is the shapefile of the Batang item. Okay, now we finish this one. We go to mapping rainfall. Similar with the code that I give to you, there is bar here, right? I call it bar or hashtag. First, you remove this hashtag. Remove this hashtag. And then you install this first. Make sure, try to be patient. Run this one. Run line or selection. Okay, my package is all already is installed. If it said warning or something like that, it's okay. There is no error. If there is error, it will tell you error. Warning is nothing. Okay, it's nothing. Now, because I have installed this package, it will not install it. Next is you go to library, the similar process here. Highlight this library because we run up top to bottom one by one. Okay. Now we run the library, run line or selection. Okay, now we load the library. Similar thing, we put this data. There is folder here. You can see if it's written like this, you need to change this folder with your folder. So now I want to change this Batang I, shape file of Batang I. So I put shape file of Batang I in this folder, right? So I copy this shape file and then I will replace the folder address only here from here and then paste and then make sure this time you put double. There is many way to read your data and sometimes people write like this and the first one I put a different way, but it's all reading the data. And then the same thing you do for chips Batang. So chips Batang here in analysis, you can see chips Batang. So chips Batang here is actually rainfall data for that Batang I. You can see the data is from 1981 year, month, and day until 2024, and it has V1 until V44. So there is 44 grid point for Batang I that we have extracted the rainfall data. So this is grid Batang. So you copy the folder address where you put that chips Batang dataset and then change this folder address. Make sure make it double and double. Okay. The similar thing, grid Batang just now where you put grid Batang. So grid Batang is also here, which is the lat long of that dataset just now. You put in the same folder address. So if it's the same folder address, you can just copy this and then paste it here. So you get the same folder address. Now from library until down there, you can highlight. If there is something like this written down there, that is another section. You stop. Then you highlight this one, only this code within this section. And then you can run line or selection. Now you have mapping of mean annual rainfall for Batang I based on chips rainfall graded dataset. You can see that the rainfall is very high in the northwest of Batang I, and in the downstream area, lower rainfall. So people who are familiar with Batang I, you know that down here in the bottom short southwest of this shapefile is actually the downstream area, the outlet of this basin. So this is rainfall, mean annual rainfall. Next, we convert that daily data just now to annual data because we want to do plotting for annual rainfall. So that we can see the pattern for annual rainfall. Annual rainfall, easy for us to see the pattern in terms of climate compared to daily. Daily will be very messy, right? So we aggregate that to either monthly or annual, and then easy we can see the natural pattern of climate in our study area. So in this case, we convert daily data to annual first. So if there is bar hashtag in the front of this installed package, you remove these packages and then you highlight it and then run it. So mine is already installed, and then run the library, and then you change the folder address. The same thing. You copy the analysis where you put your data set. Okay, until put here, and make sure the direction of the bar is similar with the original. Okay, with the original code. Okay, now chips Batang is put here in analysis. Chips Batang annual also, the output will be, we put the output also here. You just copy it up here where you put data set, and then you can paste it here. So it will be in a similar folder. Now you run this data set. This will convert your daily rainfall into annual rainfall. So just highlight until the end of this section. You run this, and then it finished. Now it's very fast. So that's why we use R. Okay. So the output will be chips Batang annual rainfall. So you can open this chips Batang annual chips Batang annual. Okay. This is the output. So you can see this is our output just now. We calculate from we convert from daily to annual rainfall. You can see that every year, this 1981, 4,087 rainfall until 2024. So we have convert that data. Now we plot that annual rainfall. The same thing for here, the hashtag, you remove this hashtag in your code, and then you highlight this one, and then run line or selection, and it will install. If it's already installed, it will not install anymore. Otherwise, it will install. You need to be patient. Wait until it finishes install. Okay, and then run the library. Okay, now we put our directory here. This is directory we must change where we put our data set. So this is different way to they read the data. They read the folder first, and then they read the CSV file after that. So you change the folder address here with where you put your data set. Just copy this analysis, and then paste it here. You change the direction so that it will be similar. Okay. Anything else, you don't need to change anything. And then you highlight this one until print P1, until the end of that section. Now we run this. And now we run this, and then it will plot the annual rainfall. So we run this line or selection. So we run line this selection. You can drag this photo. Sometimes you see that, oh, where is your plot, right? Actually, it is at the back. Sometimes this happen, it's hidden in the back. Okay, so you can click. It might be hidden in the back. So you can play around with this one so that you see the x-axis is moving around, right? So you want to make it proper, something like that. But it's okay. You in this plot, you see the bar plot of annual rainfall, and there is the rate of increasing or decreasing rainfall, annual rainfall in Batang actually. It seems to be a little bit increasing, but not. I don't think this is significant. So this is the pattern of annual rainfall. Okay, next. The same thing, you install the package first. You remove this hashtag. Remove this hashtag. Highlight this installed packages, and then run. And then you click OK, and everything will be installed. And then you load that library. Run. Okay, now it's okay. And then you change your folder address. Similar thing, you change your folder address. Take the folder address where you put your data set, put it here, make it into the bar into the same direction. Okay, that's all. And then you run this highlight until the end of this section. Make sure always save your script so that you will not missing anything. And then run line or selection. Okay, now you can see this is frequency of rainfall intensity in Batang Aiden. Now there is higher than 60 millimeter rainfall, 31 to 60 millimeter rainfall, 11 to 30 millimeter, and 1 to 10 millimeter light rainfall. And the frequency based on 44 grid point just now. So this is rainfall intensity. Next, we look at box plot. This is the same thing. You remove the hashtag and then you run this install package. Run. You see some of my package is outdated. Now it's installing the latest one. Now until it finishes, you see the red bar here and then it's okay. Now you load the library. Okay. You load the library. Now you change the, you see set working directory here. And you change this directory with your dataset where you put your dataset. So I will copy this folder address and paste this here. Make sure the bar is in the other direction. And then from library until the end of this section, I will run this selection. Highlight first, run this line. Now this is your box plot for mean annual rainfall in Batang Aidem. We can see that in this Batang Aidem, it's really follow the northeast monsoon and southwest monsoon pattern. Like start from November until March is higher rainfall, and then transition period is the green one from April to October, and then May to September is relatively dry period. Now, after that, we calculate mean grid rainfall. Just remove this hashtag and then run this install package. Okay, it's already installed. And then load the library and then change the folder address. So this is the folder address, copy, and then you highlight this, paste. Okay. Change exactly like how I show you here. Now you run the library until the end of this section. Okay, here. It's running. Okay, now it's calculate the mean annual rain of Batang Ai. So you can see this data set will be appear mean annual rain for Batang Ai. And just now it's based on temporal, right? Now it is based on each of these grid point, special rainfall in Batang Ai. Next, we now that we understand the pattern of climate in Batang Ai based on the observed CHIPS dataset just now. Now, next is we extract the GCM using homogeneous grid 0.5 degree. So this is what I need to show you actually last time. This one. So when the original CHIPS dataset is 0.05 degree, right? It's a very good fine resolution. But GCM, like we discussed last time, GCM is a very coarse resolution. At most of the GCM is 1 degree. But still, in this case, we grid the GCM based on 0.5 degree. Why not 1 degree? Because if we use only 1 degree, I think there will be only like 2 grid or 4 grid, something like that. So it's not sufficient information for us to do analysis. So this is justification. You can justify something like that because study area is very small. So we grid all the GCM to 0.5 degree. So we compare 0.5 degree with CHIPS 0.5 degree only, something like that. So GCM, there is 23 GCM. They have different resolution. Some of it 0.2, some of it 1 degree, some of it 2 degree resolution, but we regrid it to similar resolution of 0.5 so that we can make homogeneous comparison, apple to apple, everything 0.5. Okay, so this grid of 0.5 I have already prepared. That is chips, this one, let long Batang grid 0.5, this one, and also this one. I think you can see there is only 9 grid point available that we can compare between GCM, because we want to check which GCM is the best first. 9 grid point. After I have this grid point, I have extract the chips dataset for 0.5 also, because we need chips chips grid data also 0.5, so that GCM we can compare with the observed chips data for validation. All that 23 GCM we compare with chips data also in 0.5 degree resolution. Okay, next you download the GCM, right? You extract GCM using homogeneous grid resolution. You download first and then you extract to 0.5 degree. Now we rank of GCM using KGE. Now there's many way we can assess the performance of GCM. Many statistical metrics we can use, but in this case, for the training purposes and also some of the practices, some people just use KGE. There is a composite matrix for assessing the GCM. So the same thing, you remove this hashtag just now, install this, highlight this install packages and run that install packages first. Now it's it's download also. I think this is maybe there is something new in these packages. Now it's red, it's okay. Now we run the library. Run. And then you change the folder address here. All you need to do, just change the folder address. Okay, change the folder address. Just follow the similar way how it was prepared just now. If it's the bar is like that, follow it similar way. Now, what this code is doing is that it will compare all of these chips 23, all these 23 GCM, compare with chips dataset. So in your file, I have already extract all these 23 GCM. I do qualitative analysis and improve the missing data, everything in this chips dataset. Okay, but I'm not showing you how to extract the dataset, but you can refer to another tutorial for this one. I have tutorial for this one. Do refer for that one, how to extract this GCM. But in this case, I have extract that GCM, and you can use this GCM. If you open this GCM, you can see rainfall for each of this GCM, daily rainfall. Now, all of this GCM is daily rainfall at 0.5 degree resolution. Okay, now we want to do validation. Run from the library, run all that GCM and chips dataset just now, and then run. And then it will calculate many metrics actually. This code calculate many metrics. All the metrics will be prepared and will be shown in the validation. So the output will be this one, validation. So you have 23 of this, right? 23 item here, all the validation. If I click this one of the validation, so I give many metrics there. There is about 27 metrics we use to compare the performance of the GCM. But in this case, we run all the metrics first, but we still not rank the GCM. We just run all the metrics. You can play around with this result also. You can see which is more important, something like that. Okay, next, we just use KGE. Okay, we want to use only KGE to ranking the GCM, and then you change this folder address also. Copy the folder address of your laptop, and then paste it here, and then put its double bar, and then you run everything until finish for this section. You run, it's very fast. Now you get this combined KGE value. So you have combined KGE value. Let's see here. So I'm only extract the KGE value assessment for all these 23 GCM just now. Okay, now I want to rank. If you look one by one, something like that, it's very difficult. You have many grid point, right? Many grid point. Which one is better GSM? It's still very difficult. And we can visualize this by using heat map. So I'll show you the heat map. Same thing with the heat map. The next step, you remove this hashtag, install that packages first. So I'm also installing this one. There is some update maybe for P heat map. And then you run the library. And then you run from the library until the end here. Make sure until the end here, not something like this. Something like this. You must make sure everything until the end here is highlight. And then you run. You have your heat map. So this is a very good heat map, very advanced one. It's properly arranged based on average, based on average value. So you can use this result also to select your GSM. The best GSM is the red one here. Access ASM1, CMCC, ASM2. This is already ranked the GSM based on the average value of KGE. That's another way to rank the GSM. If here also you can finish, select the GSM, 5 top GSM or something like that. Okay, but we take the objective approach. We use CPI, which is Compromise Programming Index, to select the top GSM objectively. First, same thing. Next step is install this package also for the next step. Run, and then run the library. Run, and then change the folder address. You see this folder address. Copy, change the folder address. And then for the library, you run until down here, until finish. So it will rank the by using GSM by using CPI. So you have this new file, CPI summary. CPI summary, okay, from KGE. So this is the CPI value. So it's ranked the GSM by using compromise programming index, not based on average. So this is more reliable. Okay. So this is the rank of the GSM from number 1 until number 23 here. But we don't know which GSM, how many GSM we need to select for the top one, right? So we use Fisher-Jeng. In this case, we use Fisher-Jeng. Next plot, next analysis, we use Fisher-Jeng to classify how many top GSM you want to use. So you remove this bar, and then you install these packages for Fisher-Jeng. This is the method for classification. So install packages. Okay, now it's finished. It read here, it finished. Now you run the library, and then you change the folder address. This arrangement similar with the first one just now. You copy folder address, just change the folder address here. Okay, make it double, and then make it double. And then run from the library until finish here. Okay. Until finish of this section. Now you can see the ranking of the GSM. So the top 5 GSM here is group 7. All yellow here is the top high GSM. Or you can look at the output. Here output is CPI Fisher-Jeng. So CPI Fisher-Jeng classify. This is the rank just now. So this similar group is the highest top GCM. So this is the best GCM, that top GCM that we need to consider for next analysis. And we visualize this one by using this bar plots just now. Next is we look the independence of the GCM, right? There is 5 GCM top GCM just now, but these 2 GCM actually come from the same institution. These 2 GCM easily like GCM that the same first name, something like that. These come from the same institution. So the lowest rank of the same institution, you can remove this one. So the remaining GSM will be excess ESM 1.5. Excess CM2 you will delete. You don't need to use this one. So you need to use this for GSM that is independent in terms of produced by different institution to avoid any bias. Next, we validate the GCM by using PDF, probability distribution function, of this 4 GCM. We compare with the observed data. Okay. Now we remove this hashtag also. And then we highlight these install packages, run, and then it will install the packages. And then you load the library, run. And then you change your folder address again. Folder address, just to reconfirm, choose the address, make sure double bar like this. And then from library until let's see, library until it's quite longer code actually. This is the PDF. The PDF for the raw GCM. So I run this one. Okay, now we see. I put all the statistics also in this plot. You can see the performance of each of this GCM. The easiest way to look at the performance is you look at the OVL, which is the overlap efficiency of the PDF shape. The higher the OVL, the better that GCM. The best here is actually ESM2. The second best is the green one, which is says M2. Okay, you can see the performance. The lowest performance is excess ESM15. So now after that we validate that plot just now is actually validated based on the mean monthly rainfall. Now we run for each month. We can look for each month. Yeah. I will share also this code later on. All this library you run, and then change the folder address. I think everybody get it now, right? You change the folder address and then you run this code. Okay. Now you can see the performance of the raw GCM compare with CHIPS dataset for each month from January until December. You can play around with this dataset and look at it. Next is you download the future scenario for top performing GCM. So we have this 4 GCM just now, right? This is the top GCM. So because you rank only 4 top GCM, now you only need to download each scenario for this 4 GCM. So you don't need to download all 23 GCM, only 4 top GCM. So it saves time, it saves your storage. So download SSP5. In this case, we use SSP5, okay? After that, as you can see just now, there is very big bias in the GCM. It's not simulate very well the CHIPS dataset. That's why we do systematic bias. We do bias correction to address the systematic bias in the GCM. In this case, we use a hybrid random forest. Like a hybrid random forest. Okay. This is the method that we have developed. Okay, just the same thing. Remove this bar. Install the packages first. Run, and then it will install the packages. Or update the packages. And then load the library. And then all you need to do is the same thing. You change the folder address. Folder address. Make sure the bar is the same direction. And then from the library until finish here, it will run the bias correction. So this bias correction can take some time, I believe, to run because this not quite heavy. I think it's not heavy actually, but it can take some time, depend on the performance of your computer. And then this is a machine learning approach. We use hybrid random forest. I can explain a little bit how it do this one. So we do hybrid random forest. This one in the slide. I have prepared this slide to show you how hybrid random forest do bias correction. So we in this classification that we in the hybrid part of this approach. Hybrid part is that we only first we detect if there is rain or no rain in the GCM frequency bias, because a lot of GCM they have frequency bias. They cannot capture no rainfall very well. But here we want to capture frequency bias, that GCM that can capture no rainfall and rainy days well, okay, by using frequency bias. But there is a threshold that we put here from 0.1 millimeter or something like that. And then we put intensity bias that we want to capture high intensity rainfall. And then which is the power of the random forest actually to capture the high intensity rainfall. And then seasonal variation, we do correction month per month, and then that one aggregated by using random forest into the to capture nonlinear relationship of the rainfall pattern. So, but still, the performance of this after bias correction is still not very good, right? You can see that it can produce the mean rainfall very well, especially for excess ASM 1.5 just now, right? The GCM now perform way better than the raw GCM. But still, it seems like this after bias correction, the GCM peak, the curtaceous peak of this PDF seem to be higher. A little bit higher actually. You look at the scale down here, it's already 0.004, only a little bit actually, slightly overestimate of mean rainfall occurrence. And the drawback of this method is that it still cannot capture the extreme pretty well, a little bit, slightly. I think this slightly underestimate extreme rainfall, but not so much. So there is still room for improvement for this method. So let's see our method. Oh, now it's finished running everything. So you will have this bias output later on, this one. For each of the GCM, it will bias the historical data. It will do bias correction for historical data and do bias correction and transfer that bias correction for historical data into the future GCM, future scenario. So now you have this this bias correction data. You want to see is it can perform well or not, and that is the next step. You install the GCM, install the packages, and then run the library, change your working directory, and then run all of this until the next section, and then you run. Okay, now you can see the performance of the GCM after bias correction just now. So we can see from the table just now, seems like these two of the GCM, the OVL seem to be reduced, but the GCM that is not performed very well just now, it improved. There is a drawback here, but still the GCM have improved and become more better in capturing the mean rainfall. Now we do validation for each month. You can run the library and then change the working directory just now, and then run this all. That one is only for mean rainfall just now, right? It not tell you everything. Now we look at each month, how this bias correction GCM perform. More or less similar performance, but still there is some higher peak of the mean rainfall happening by using this method. So there is still room for improvement for this method, but it is way better compared to the observed one to the GSM that have no bias coefficient. You see, if you look at GSM that have no bias coefficient, it's performed very very bad. You cannot use this GSM. You need to do bias correction to at least improve the GCM until at least it looks better. At least better, right? Compared to the raw GCM. Okay, next. But all the method for bias correction, you can check which one is better for many area, different area. And then you ensemble because we have 4 GCM, right? We have 4 GCM. So we don't want to use only we don't want to project each of these GSM. It's become confusing for stakeholder to understand the projection data scenario. So we ensemble 4 of these GCM first to produce only one single product for this GCM. So we do ensemble. Ensemble is not just taking the mean. Nobody use that anymore. It's not. People will argue you cannot just simply take the mean of the mean average of the each GCM. So the better way to do this one is at least one method that I use here is we use random forest regression to ensemble the GCM. So you can you can install the packages first to do ensemble here by using random forest. Load the library, and then you change the working directory where you put our data just now, and then run the ensemble here. Ensemble. So the ensemble will run for both historical and projection. So now it's running for ensemble for historical, and then it will run for ensemble for future projection for SSP5. If you have different SSP, you need to run different SSP. You can change this dataset with another SSP, and then you run one by one until 4 finish, and then you get all the ensemble of the different scenario. So now it finished running for historical. So the future projection can take quite more time because future projection is longer. It's until 2100. Historical is only until 2014. So after ensemble just now, we will get only one product. After that, you can do analysis. Up to you what kind of analysis you want to do afterwards. Okay, it's still running. We wait a little bit more. So ensemble, you cannot just use a mean average. The least you need to use is, what is that method? I can't remember. There's one of my paper in Johor River Basin that I do this ensemble by using that method. That method is the least method that you need to use. Ensemble. It's okay. So now we have that ensemble for historical just now, right? This is the output ensemble RF. So you go to your folder, ensemble RF here. You can open this data set. So now you end up with this ensemble data. Only one simulation. Okay. You only have one simulation for ensemble model. Okay, future projection also finished. This is ensemble. So this is the final product that you have for future projection. This is under SSP5. So this is projection from 2015 until 2100. So this is the final product. You can play around with this dataset, whatever analysis you want to do. So this is daily rainfall projection for Batang I from 2015 until 2000. Not the ensemble. This is still the ensemble one. We need to do delta bias correction later on, but it's okay. We look first. We have action just now, and this is the final step. You do downscaling. You do delta based pattern scaling method. So our GCM just now it's like this, right? It's like this. We upscale to 0.5. Now we need to downscale to 0.05 again. To do downscale back here, after we select the best GCM and everything, after we do bias correction, after that we do adjustment step. This is we call adjustment step. We aggregate back 0.5 into 0.05 degree. Okay, we do this step. Just install again this packages, install. Okay, and then run the library. And then similar thing, you change this folder address and then run this code, this section. Now we downscale it from 0.5 to 0.05. Okay, now it's finished very fast. So this is the final one, delta. This is delta for historical. This is now it going back to 44 grid point, right? Until 44. From this is projection, and then this is the historical one, 1981. Okay, and for 44 grid point, so we have downscale it back to 0.05, which is the GCM that has been bias correction based on the photo GCM, and then it was also ensemble. So this is the final product, your delta downscale data set. Now you can play around with this data set. You can do projection of monthly time series. You run that projection just now. You can do this is a bar plot of time series from 1981 to 2100 to check what is the projection looks like, and then you can map that data set. You run another code, just change the library, install yes, and then change the folder address. You can compare the historical and projection, and then you can look at the intensity of the rainfall. How does extreme rainfall looks like in the future? This is how it looks like in the future for Batang Eye. And then we look at the each period of the future. We look at the future period from near future, middle future, mid future, and the far future. How does it looks like? And then we do like a simple trend assessment to see the rate of change over the years for each. And this one is for the whole period, but we the best way to look at it is based on each period. Each period, okay, like this one. Each future period, near, middle, and far future. Now we can see how the rate of temperature rainfall change in Batang Eye. Now it's easier to give this information to other people. And then we do PDF, PDF for future period, to differentiate between how the annual rainfall pattern differentiate between different future period. And then you can do monthly also. Use the same process that I showed you just now. Just install the library, load the library, change the folder address. Now each month you can see the pattern of rainfall in the historical, near, mid, and far future for each month. Now we look at the monthly time series. So all the rest is like you play around with the output just now. What you want to know. This is monthly rainfall, the pattern for each future period. I have put a more advanced one with variability also here. This is how people like to show their plot actually. There should be some variability based on standard deviation. And box plot also very easy. You can see many outlier or something like that, the range of rainfall. to understand how rainfall change in the future period. And then you map based on the future period. This one, the last code is to see mapping of rainfall, especially in the near historical year, near, mid, and far future. So when we present our data, we show it temporarily in terms of annual, monthly, PDF, box plot, and then we also show a special map like this. Take a mean of future period, future calamity period, like 30 years, 30 years, 30 years. Okay, I think that's all for this tutorial. I hope this will be very helpful. If you have any question or you have any analysis that you want to do specifically or any help, just let me know. Okay, I can prepare the tutorial. It's anything that I say will be the same thing with what I say in the YouTube. So this will be this tutorial. I hope will be very helpful for everybody. Thank you for watching.